If you've ever written even a single line of Java, you've used the object class. You might not have even known it. Today, we're going to pull back the curtain on this super fundamental, often kind of invisible part of the language. This thing is the universal blueprint behind every single object you create in Java, and really getting a handle on it is key to writing much better code. I'm sure we've all been there, right? You create this perfect object, you go to print it out, expecting to see all its nice data, and instead, you get this cryptic-looking string. What on earth is that? Well, by the end of this explainer, you'll know exactly what it means, why it happens, and most importantly, how to make it print out exactly what you want it to. So here's our game plan. First, we'll get our heads around why the object class is called Java's universal parent. Then we'll tackle that annoying printing problem using the toString method. After that, we'll dive into the pretty tricky business of defining when two objects are equal with the equals method, and we'll uncover its inseparable partner, hashCode. And finally, we'll wrap it all up with the key takeaways to make sure this stuff really sticks. Okay, first things first. In the entire world of Java, every single class, and I mean every single one, whether you write extends object or not, it automatically inherits from this master object class. Think of it as the ultimate ancestor, the universal parent of everything. So what's the big deal with that? Well, it means that even if you create a class and leave it completely empty, it's not really empty. It automatically gets a whole set of foundational methods for free. We're talking about methods like equals, hashCode, and toString. These come straight from the object class, and they provide a common, predictable blueprint for every object in the entire Java ecosystem. All right, let's solve that first mystery, that weird, jumbled output you get when you print an object. This all comes down to a method called toString, one of those freebies we just mentioned. To make this super concrete, let's just imagine we have a simple laptop class. All you need to know is it holds a couple of pieces of data, a model name, which is a string, and a price. We're going to use this laptop class as our running example. This slide shows our problem and our goal perfectly. On the left, we print our laptop object and get that useless string. On the right, that's what we want, something a human can actually read, something that tells us about the object's data, like Lenovo Yoga, $1,000. So how do we get from point A to point B? The key is to understand what's happening under the hood. When you try to print an object, Java automatically calls its toString method behind the scenes. And the default version, the one we get from the object class, is designed to just return the class name, followed by an @ symbol, and then this number. That number is the object's hashCode, just displayed in a different number system called hexadecimal. It's basically a numeric representation of the object's location in memory, not its actual data.
So here's the solution, and it's a huge concept in Java. We can take control. We do this by overriding the default toString method. In our very own laptop class, we just define our own method with the exact same name and signature, public string toString. And inside that method, we can build and return any string we want, using our object's model and price fields. Now, when we print the object, our new method gets called instead of the default one. Simple.
Great, so we've totally solved the printing problem. Now let's move on to the next big challenge, comparing objects. This is where we really need to understand the difference between what an object is versus what data it holds. Let me ask you a question. Let's say we create two separate laptop objects. Laptop 1 is a Lenovo Yoga that costs $1,000, and laptop 2 is also a Lenovo Yoga that costs $1,000. Now, you and I, logically, we'd say, yeah, they're equal. But what does Java think? This is where things get a little weird. If we use the double equals operator, double equals, to compare them, Java says false. That's because double equals is checking for identity. It's asking, are these the exact same object at the same location in memory? And no, they're not. They're two separate things. But here's the real kicker. That default equals method we got for free from the object class, it does the exact same thing. It just checks the memory address, so it also returns false. And the solution, you guessed it, is to override the method again. We have to teach Java what it means for two laptop objects to be logically equal. We do this by writing our own public Boolean equals method. Inside our version, we totally ignore the memory addresses. Instead, we compare the actual data. We ask, is the model string the same? Is the price value the same? If all the important data fields match up, then we return true. Okay, now we're at the final and I would say the most important rule of this entire topic. The moment you decide to override equals function, you enter into a contract with Java. It's like a sacred pact, and you absolutely, positively must also deal with its partner, the hashCode function. This right here is the contract. You should memorize this, write it down, whatever you need to do. This is a huge point for job interviews, for exams, and for just writing code that doesn't break in weird ways. I'm going to say it again. If object1.equals object2 is true, then object1.hashCode must be equal to object2.hashCode. There are absolutely no exceptions to this rule. So why does this matter so much? It's because a ton of Java's most important data structures like hashmap or hashset completely depend on this rule to work correctly. Think of the hashcode as the label on a drawer in a giant filing cabinet. A hashmap uses that hashcode to figure out which drawer to put your object in, or which drawer to look in to find it later. If two objects are equal but they have different hashcodes, the hashmap will look in two different drawers and think they're two completely different things. It causes all sorts of chaos. So the takeaway is simple. If you override equals, you must override hashcode, period. Okay, we have covered a lot of ground. Let's just do a quick run through to make sure these core ideas are locked in. So these are the big three from the object class that you really need to master. toString is for getting a human readable string, which is amazing for debugging. Equals is where you define what it means for two of your objects to be the same based on their data. And hashcode is its required partner, which makes sure your objects play nice in collections. Now for a huge best practice tip, and trust me, this is a lifesaver. Writing correct equals and hashcode methods yourself can actually be pretty tricky and it's easy to make a mistake. But your modern IDE, whether it's IntelliJ, Eclipse, VS Code, it can do it for you perfectly. You can literally just right-click in your class, find an option that says generate or source action, and then pick generate equals and hashcode. It will write a robust, correct implementation for you in seconds. Always do that. And that brings us to our final thought. What we've just done is unlock the ability to give our custom objects real, meaningful identities. And that's the foundation for using them in powerful ways. So the question I want to leave you with is this. Now that you can properly define and compare your objects, how does this empower you to store, search, and manage them by the thousands or even millions in Java's awesome collection frameworks? That right there is where all this knowledge really comes to life.